Major support for Do the Math has been provided by Chevron, the Kern County Superintendent of Schools, Edison International, Valley Strong Credit Union, Panama Buena Vista Union School District, and the Kern High School District. With additional production assistance provided by these supporters of education in Kern County and throughout the state of California.
Well, good afternoon and welcome to Do the Math. I'm Michael.
I'm Marylou.
And I'm Ryan. For math homework help, call in Bakersfield 636-4357. Everywhere else, 1-866-636-6284. Email is dothemath@kern.org, and we're online at dothemathonline.net. Our social media is Facebook, Instagram, Twitter, and YouTube.
Nicely done, Ryan. So let us know where you go to school and what grade are you in?
I go to school at Warren Junior High, and I'm in 7th grade.
So a little bit of a different year for you now because you're now in junior high, so you've got a lot of different instructors for different classes. Do you like that?
Yes, I do.
So it's better, so you like that better than just having one instructor all day?
Yes, I do.
Do you have homework from every single one of them all the time?
Oh, yes. No, not all the time.
But most of the time?
Yeah, yes.
So how many different classes do you have right now?
8.
Ooh, that's pretty good.
Yeah.
All right, so you must be in band or something like that also?
Orchestra.
Orchestra. All right, and what do you play?
And I play the viola.
Good. Well, you know what? We have somebody from the music department with your school district here today, so maybe you guys can talk a little bit about music also, right?
Yeah.
All right. Hey, you know what? Before we get started with all of the day's activities, just a reminder, this is the opening day, like baseball, right? The opening day, first show of the season for season 22 of Do the Math. So we really want to say thank you to the Kern County Superintendent of Schools, as well as all of our major supporters and those that give us lots of different things and support throughout all of the years to keep this program going for 22 years. Those of you that are new to the program, it's basically a homework help show for you. So if you need help with any type of mathematics, regardless of the type of math, what grade you're in, how old you are, anything like that, if you need help, we are here to help you out. On Tuesdays and Wednesdays, you can phone us between 3:30 and 5:30. The show is live, as you're watching right now, between 4:30 and 5:30. A lot of different ways you can view the program, a lot of different ways you can get the help. It'll all be on your screen at the bottom of the screen throughout the day. Ryan gave you a rundown of all the different ways you can contact also. And if you happen to phone in today and we do one of your math problems on air, you will automatically receive a pass to the Kern County Fair, which begins next week, I believe.
Next week?
Right, next week. Already fair time.
Wow.
So we know it's going to stay hot out because it's always hot during the fair, and it won't get cool until after the fair. So anyway, you call in today, you're going to get yourself a pass to the great Kern County Fair. You ready to do a little work?
Yes, I am.
All right. Well, the first thing we're going to look at today is today's problem of the day. This is always posed on social media, and we need to find the mode. So, Ryan, do you remember what mode even means?
Middle.
Middle. All right. Well, let's take a look. Those numbers, we have 9, 12, 15, 15, 12, 12, 12, 9, and 15. Do we leave them in that order, or do we do something to them first?
We put them in least to greatest.
All right, so that's the important thing. You need to put them in order from least to greatest. Now, if you're driving down the road and you see somebody coming towards you, in the middle of the road is usually a concrete thing, and that's called the median. So do you think the mode is still the middle?
No, it's the repeating number.
Oh, okay, the repeating number. So there's a lot of numbers that are repeating. Could there be more than one mode?
No. Wait, yes, there could. Yes,
There could be, right?
Yes,
It's possible.
Yeah.
Could there be no mode?
Yes.
There could be, right? Based on different sets of numbers. So let's take a look. The nines. How many nines are up there?
2.
All right, let's take the next highest number, 12. How many 12s do you see?
4.
And what about 15s?
3.
So what do you think the mode is?
12.
All right, let's see if he's correct. 12 is correct. Nicely done, dude. First one done. All right. 636-4357 is the phone number. We do have phone tutors available until 5:30. As I said, most Tuesdays and Wednesdays throughout the regular school year. Time now for today's Math in the News. All right, and today's Math in the News, we are fortunate enough to be joined by Daniel Williford. Daniel, how are you today?
I'm doing great. Thank you so much. I'm so happy to be here. What an exciting program.
Good. I'm glad you're here. So you are with the California State Parks, correct?
Yes, I am. Yeah, my name, as you said, is Daniel Williford. I'm with California State Parks, and I am the coordinator of the Adventure Pass program.
Okay, so the Adventure Pass program, this is aimed at fourth grade students, correct?
You got it. So what it is it's a free day use pass for fourth graders to get into 19 select parks throughout California, and not only the fourth grader, but their families and friends who are there with them. And they go online to our State Park Adventure Pass website and sign up for their free pass. And it's good for an entire year from September 1st to August 31st. So there's a lot of time to enjoy this incredible pass.
Yeah, I was going to say, and a lot of different scenes that we're looking at right now from a lot of the state parks. Why, Daniel, was this targeted for fourth grade students?
Well, that's an excellent question. Well, the curriculum taught to fourth graders in the topics especially of history and science, well, that matches really well with what California State Parks has to offer. So by providing free day use for fourth graders, it provides a great supplement to what they're learning in class. Not only does it reinforce what they learn, but it hopefully can expand upon what they learn and put it in a whole new context.
Well, I was going to say, because the students could learn a lot about this in class, but then when they're actually able to go to the state parks and experience it and see firsthand what is available at these parks that you guys are being able to offer them for free. I mean, that is a big thing right there. How many different parks are available for students to go to?
So for the Adventure Pass, there's 19 select parks throughout the state of California. So you can see behind me, there's the train right there. Well, the California State Railroad Museum is one of our participating Adventure Pass parks where you can learn about the railroad industry and actually go on to train. Right over here, right over here, Bighorn sheep spotting at Anza Borrego Desert State Park, another one of our parks. But more closer to Kern County, there's a few others. There's just up the road from Kern County, there is Colonel Allensworth State Historic Park, which is an exciting new park for me. I didn't know much about it, but it's a historic village settled by African-American pioneers in the state of California. And students can go and check out an old schoolhouse, an old library. There's even camping there. Camping's not part of the Adventure Pass, but the day use aspect.
And I know that you're also talking about one a little bit north of Bakersfield. There's also one relatively close on the Central Coast.
There is one of my favorite areas, Morro Bay State Park Natural History Museum is part of our program. And I know it gets hot in Bakersfield, so going to Morro Bay is a fantastic way to spend the day or the weekend. I know it's a little far, but Morro Bay State Park is also a part of this Adventure Pass program.
Yeah, and I know a lot of students, especially when they get into sixth grade and experience Camp Keep, they have an opportunity to go over the Central Coast, pretty close to that also, and do some things there. So
that's great. So there's already a connection with Morro Bay and Kern County. I love it. That's wonderful.
Yeah, well, I'm glad you brought up the heat because it is hot in Bakersfield, and going over to the Central Coast is always a treat. And when you can do it for free and visit a state park, that makes it even better. So Daniel, I know that this is aimed at the fourth grade students, and you explained a little bit why it was fourth grade students. What about students that aren't in fourth grade? Are there some passes for them to take advantage of also?
There certainly are. So there is the Library Parks Pass. And if you have a library card to your local library, go and check out the Library Parks Pass. And it can actually get you into about 200 of our California state parks. So it's a wider group of parks that this pass lets you in. And that's for any age with a library card. So yeah, very exciting. Yeah, you have this great video right here showing all about the library pass. So that's any age. So super exciting, all these ways to get into our state parks for free. Because we really want people to enjoy our state parks. We live in such an incredible state full of all kinds of natural and historical wonders. And it will be incredible for everybody to be able to experience.
Yeah, I was going to say, I wish I was in fourth grade again, or at least if I had a fourth grade student again, so I could go to the parks and stuff like that. But Daniel, I know that a lot of students, they start thinking about what they would like to do as a career. And fourth grade students, certainly not too young to start thinking about it, but older students, especially in high school maybe, might start thinking and seeing this going, hey, you know what, I like being outdoors, I like going to state parks. What are some career options for students to look forward to if they'd like to work in the state parks?
Oh, there are so many great opportunities. I'm a state park interpreter, so I lead a lot of the educational programs. But there's not only is there educational type rangers, but there's law enforcement rangers, there's maintenance, there's trail planning and resource management, people who help to restore the land after it's been damaged, all kinds of things. And let's say you like the outdoors, but maybe you don't want to be outdoors all the time. Well, there's a whole group of people inside in an office that go out to the parks when needed that help behind the scenes too. So like archaeologists and historians and all kinds of really exciting disciplines that are a part of state parks that make our system of 280 parks run. So yeah, lots of opportunities. If you're looking to for a career with state parks, there's many ways to be involved and to contribute.
Yeah, those people behind the scenes are very important. Just like this math program, there are a lot of people behind the scenes to make this go. Everybody sees Marylou and the star of the show, Rayan, and they're like, the old man's out there too. But there's probably close to a dozen people in back making sure everything works, as well as getting you on the program. Daniel, if somebody wanted to go and check out and meet you, are you based in Sacramento or someplace else?
I'm based in Monterey. But now all of the Adventure Pass parks are my parks. So if you're in one of the Adventure Pass parks, you may see me there helping out with what's going on. One of the things that I coordinate is to make sure that these parks have what they need for the Adventure Pass user and their families. So we want to make sure that there's programs and recreational opportunities that the fourth graders know about and go and experience. So that's part of what I do, is getting that word out there and making sure the parks have what they need to make this a successful program.
I know you're going to be busy with this. If students want to find out more, and parents, where do they need to go to find out about the pass to get this?
Right here, you've got it on on the screen, and I'll even add to that, after the www.parks.ca.gov/Adventure Pass. Okay. And that will take you right to the Adventure Pass.
There you go, Adventure Pass.
But so will this will too. That web address will take you to that as well. So.
All right. Well, Daniel, thank you very much for your time today. It was great finding out a little bit more about the Adventure Pass and the Library Pass for students that aren't necessarily in fourth grade right now. A lot of stuff to look forward to during the entire year. Kind of wish you were back in fourth grade now, huh?
Yeah.
There you go. All right. Daniel, thank you for your time.
Thank you so much. I really appreciate it.
All right. 636-4357 is that phone number. We do have phone tutors available until 5:30. Quick reminder, you call in today, we do your math problem on air, you get yourself a pass to the Kern County Fair, which starts next week. In studio, we have a 7th grade student from Warren. This is Ryan, and Ryan is going to now help us out with integers. Yeah. So how about you and Marylou go over to the board. We'll put a couple of these up on the camera so that the students at home can play along also, and see if they can work them along as you guys do as well. So the first one we have is -8 plus -6. And the -6 has parentheses around it. So Ryan, go ahead and kind of explain to Marylou what's going on and how you would like to solve that.
So -8, so the math problem is asking us to add -8 and -6. These parentheses are to isolate the negative from the positive. So we don't think that this is +6. So to solve this, we have to look at the signs. Now, there's a rule in adding and subtracting integers. If they have the same sign, they are negative. No, if they have the same sign, they're positive. But they have the different signs, they're negative. Okay. Now, so we bring down the -8. Then, if it's going to be the same sign, then it's not negative, because positive and negative, they're both different signs, so that turns them negative. Okay. So, -8 minus 6 equals -14.
So on this, so we have -8 plus -6. So it's really telling us, from what I was hearing you saying, if we have -8, we're adding another -6. Can we think about this on a number line? I love the way how you have the 2 double, right? And you've switched it to 1. It's almost like you've simplified that, right? But let's think about this on a number line. So when we have our number line, I'm going to put 0 here, and I'm going to put +1 here. And is it okay if I skip count by, well, let's do +2. So we could skip count by 2s, okay? So we have -2, -4, -6, -8, -10, -12. Am I going to make it? I'm going to make it. -14. So what you're really saying is we're starting at -8, and we're adding on
-6.
-6. Can you show me on the number line what that would look like?
So we start at the -8 right here.
Okay.
And if we're adding 6, that means we have to jump over 3 times since it's been skipped by 2s. So it's 1, 2, 3. And this is -6 in total of the jumps because we are skipping by 2. So this is -14 is the answer.
So, and then again, remember that when we are moving to the right on a number line, we're always adding. But if we're moving to the left, we are subtracting. And how you've simplified here, -6 and -6. So we're starting at -8, subtracting 6 over, and we're getting at
-14.
Nicely done.
All right, clear that board. We've got another one because those
Right,
had
I
the
got
same
it.
signs.
There you go.
Now we'll do one with different signs. So let's take a look at the next one. And we have 5 plus -2 with the -2 in parentheses. So you can go ahead and write that up. And
Ryan, I'm going to ask you to show me 2 different ways to solve this, okay?
Okay. So the first way is to just change the signs like I said before.
Okay.
So when they're different signs, this is a positive and negative sign. When they're different signs, they're always negative. So it's basically saying 5 minus 2, and that equals 3.
So is there another way you can show me?
With the
Besides
number.
using the number line, is there another way?
Well, you could use the absolute value of these numbers.
Okay, explain that to me.
So the absolute value is basically the distance of a number from 0.
Okay.
And absolute value is never negative because there is no negative distance. So the absolute value of 5 would equal 5, and the absolute value of -2 would equal 2. Because this is basically the opposite of each number if it's a negative, but if it's positive, we keep it. So, and then from here, from this sign right here, the original sign, we would say 5 minus 2, and that would also give us our answer of 3.
All right. There you go.
Yeah.
well done, well done.
Nicely done.
So you feel pretty confident with integers and how to deal with them and stuff like that, right?
Yes.
And what about multiplying them, dividing them? You feel pretty good with that also?
Yeah.
All right, good. Well, you know what? For your great effort so far today, you've got yourself a meal courtesy of our friends at Chick-fil-A, so congratulations on that. Have you ever had Chick-fil-A?
Yes, I
Oh, that's some good stuff
it is
right there. Let me
very
tell
good
you.
stuff.
What's your favorite thing there?
The chicken nugget.
I thought you were going to say the chicken, all right. But you like the nuggets more than the sandwich?
Well, no, the sandwich is
The
better.
sandwich,
Oh, so you like
Yeah,
the sandwich?
yeah.
All right, well, there you
I don't
go.
know, the French fries.
Yeah,
Do you know who Pythagoras was?
I do know the Pythagorean Theorem.
The Pythagorean Theorem.
Yeah.
What do you know about that? Can you remember anything? I know I'm asking you off the top of your head, but.
Yeah, but a squared plus b squared equals c squared.
Nice.
And how would you kind of use that? Do you have any idea? Like,
So
because I know you've done it in class.
yeah, I have.
Right?
Well, 2 squared plus no.
Yeah, you're right.
You're right.
You've got it.
Okay.
Right?
Can I throw a
But
picture up?
well, not yet, because we have something in store for you, because we have a brand new segment called Let's Talk Math. And this is where we have students come in and talk about a math concept that they're kind of the expert in. And right now we're going to find out a little bit more about the Pythagorean Theorem.
Good job. Hey, nice job.
Hello, my name is William Plank, and today I'm going to be explaining the Pythagorean Theorem. Now, the Pythagorean Theorem is a squared plus b squared equals c squared. Now, the reason why it's called a squared and b squared is because when you're drawing a right triangle, which I'm not very good at drawing straight lines, but just pretend this is a perfect triangle. So you have A, B, and C. So the two legs at which is squared, when squared, equals C. Because you see, on every single triangle you see, the longest side is always called the hypotenuse, facing the two legs. Now let's get an equation for us. So we'll have 6 squared and 8 squared. Now, this is just one of the easier problems, just to give you an idea of what it is. Okay, so we have 6 squared and 8 squared as our substitutes for A and B. Can't forget squared. So 6 squared equals 36 plus 64, which is 8 squared. To get, well, we'll have to find out. 64 plus 36 equals 100. And this is one of the best case scenarios because 100 happens to be 10 squared. So if you take the square root of 100, it equals 10. Now that's your answer. Now it's not always going to be that number. Sometimes it'll be different and you're going to have something that looks like this. So I'm going to draw another triangle and we're going to get 7 squared and let's do something random, 9 squared. So we have 49 plus 81, which equals, you'll have to find out, 81 plus 49, 130. Now there isn't any perfect squares, so we'll have to see what the numbers that are squared are in between 11 squared and 12 squared. So in between those numbers, you have 121 and 144. So in between there is our answer, 130. So we'll have to see what the closest decimal. We have to do decimals. So let's see, 11.5 times 11.5 . Add them all up. And you get our answer. Make sure to add the decimals. You get 132.25. Now that's not quite the answer, but with a little trick of if you do some squiggly equal signs, that's approximately 11.5. And 11.5 is approximately 130. Now, that's just a little bit of Pythagorean theorem. I'm not the best at explaining it, but I feel like that the Pythagorean theorem is the base level for a good foundation for geometry. My name is William Plank from Do the Math.
There we go, one of our first segments of Let's Talk Math with some of our younger experts,
Yes.
shall we say. And it's nice to have all of these associates now,
Yeah.
right? Start bringing them up, and then when we retire, do the math, keep on going on and
Yeah,
on.
well done on that.
All right. Well, we have Ryan, a 7th grade student from Warren Junior High, in studio with us today. Did a little bit with integers, and right now we're going to take a look at a problem that isn't so straightforward. So let's take a look at it together, and you guys at home can play well. An expression involves subtracting two numbers from a positive number. Under what circumstances will the value of the expression be negative? So you guys think about it, write down whatever you need to. We'll go through it one more time.
So how many numbers are we dealing with right now?
3.
3, okay. So we need it's two negatives, one positive.
One positive.
Okay, think of 2 negative numbers and 1 positive number.
Okay. Negative 20. The positive number would be 5.
Okay.
And another negative number would be 10. Just dealing with easy numbers.
Okay, so what is it that we're trying to solve overall?
So we're trying to solve 2 negatives when they're being added by a positive number.
And the answer needs to be a
Negative number.
negative. Okay, so let's solve this problem that you did right here.
So 20, these are like terms, the meaning that they both have the same sign. So if we look at these, this 20 plus 10 is 30, but their sign is negative. So it's negative 20 plus negative 30.
So we're grouping, like you
Yeah,
talked about
grouping,
like
yeah.
terms, we're grouping those terms together and
Yeah.
we're adding them.
Yeah.
Okay, so what's the solution for negative 20 and negative 10?
So it's negative 30 plus 5. We bring this 5 down here. And then so 30 minus 5 is 25. But since we're keeping the sign of the bigger number, it is negative 25.
So again, let's think about that number line, right? That number line, we're at negative 30, we're adding a positive 5. So if we're at that number line, we're going to the right, but we're only going over 5.
5, yes.
And again, we know that the numbers really, they're going opposite on the left side, right?
Yeah.
So we're going to negative 25. So my wonder is, what would be the smallest numbers that we could use for negative to still get a negative answer?
So we could use negative 1 plus 1 minus 1. So all in ones.
Okay.
So these added together would be negative 2. And then if we bring down this 1, so plus 1, we would still end up with negative 1.
So that's the smallest that we can get.
Yeah.
Whole numbers, right?
Yeah,
Integers.
yeah.
We're not talking rational. We're not talking decimals
Yeah.
or fractions
Yeah.
because we could get even smaller, right?
Yeah, we
Different
could.
numbers, right?
Yeah.
But with whole numbers, this would be the smallest we can use.
Yeah.
But if I said, what's the largest, would there be an answer to that?
No.
It's
'cause
like infinite,
it
right?
could be infinite, exactly.
Okay. So did we answer the question, Mike? Yes?
You did. And I was going to say, if we made a word problem out of it, you could start writing math books after that.
Yeah.
Right? So anyway, that'll be an extension on that one right there. Nicely done.
job.
Hey, we do have phone tutors available until 5:30 most Tuesdays and Wednesdays throughout the regular school year. Time now for a little music in our lives. All right, the math and music we are fortunate enough today to have from the Panama Buena Vista Union School District, one of the music program instructors, Ambra, with us today. How are you?
I'm good. How are you?
I'm excellent. Thank you for coming in today. Where are you at? So are you at one site, more than one site?
I teach at one site. I teach at Cyber Elementary School.
Okay. And so you work with 4th, 5th, and 6th grade students, or
I work with all the kids. So
all the kids.
TK to 6th. Yeah.
Okay, so TK to 6th.
Yeah.
So you are introducing them to music, and in a lot of fun ways, because that's all music is fun, right? So
Right.
that's all you do is have fun all day, right? It's like what I
Right.
do in class too. We're doing math and we're doing things, we're having fun all day. So what will you be doing with Ryan today?
Okay. So Ryan, today we are going to be talking about time signatures in music, okay, and how that's related to math. So pretty much all music is math. But I'm sure you knew that because you
Yeah.
play the viola, right?
Yeah.
Okay. So I just want to show you really quick what I wrote on the board. We have 2 different kinds of time signatures. Okay, we have a 4/4 time, which is a fraction, and then we have a 6/8 time, which is also a fraction. So the measure The top number will tell you how many beats are in a measure. So there are 4 beats in a measure, right? And the bottom one, do you know what the bottom one means?
How many measures are in a line?
Yeah, how many of each note is in the measure? Yeah. Okay, so I wrote over here some note values. So what we're going to do is we're going to look at the note values, and then we're going to play our instruments. Okay, and we're going to make some music. So do you remember what this one is called?
T, no. Oh,
Ta.
yeah, ta.
Yeah, ta, and it gets, you know how many beats it gets?
1.
1, yeah, good. This one is called TT, eighth notes,
Yeah, eighth
and
notes,
both of those together equal to 1, but actually each one of those little dots is a half,
Yeah.
right?
Ta, ro.
Ta, oh, good. And that one is, do you remember how many?
2.
2. Good.
This one is 3 beats.
3
But
beats.
I don't know the.
It's dotted half notes, what that one's called.
Okay.
And then the last one,
Is a whole note.
whole
And
note.
it gets 4 beats.
Fabulous.
Yeah.
Good job. Okay, so Ryan, I'm going to have you take the marker, and then on 4/4, what you're going to do is you're going to plug in the counts. Only 4 fit in a measure, right? So what do you want to put on the first beat or the first and second beat? You're going to choose from your rhythm bank. Perfect.
Yeah. That's a little wonky.
No, it looks great. Okay.
And
What about
then-
beat 2?
There you go.
Perfect.
And there you go.
Awesome.
then-
Okay, so how many beats did this one get?
2.
2, right? So that one's going to take up beat 2 and 3. So let's erase that one and let's put it right there.
And then this one. Let's just, I'm going to change it up a bit.
Perfect.
Put it like that.
That's fantastic.
There you go.
Okay, good. All right, so this one's 2. So let's fill that one in and let's fill that one in because each one is 1
Yeah,
beat,
okay.
right? Okay. Perfect.
Yeah.
Awesome. Okay, so let's play it.
Okay.
So we know that each quarter note is 1 beat, so we can clap it first. So we're going to count out loud, and we're going to count 1, 2, 3, 4, and that's the end of our measure, right?
Okay, yeah.
Ready, go.
1, 2, 3, 4.
Perfect. Okay, we're going to go to our instruments, and we're going to play it. Okay, so you can grab your drum, and you're going to play 1, 2, 3, 4. Ready? Perfect. I'm going to change the rhythm a little bit.
Okay.
You ready? Okay, so we're going to subdivide a little bit. So if I have 2 half beats, I'm going to make this 2 into one of these. So this becomes half of a beat. So we're going to say and.
Okay.
Okay? So that goes 1, 2, and 3, 4. Ready? You want to try it?
Okay.
Ready, go. Very good. So we did 2 beats, 2 notes on 1 beat. So let's change this one out. What would that one be?
4
4
and.
yes. So ready, let's try it. Ready, go. There we go, good. And then we can do one more. Let's change this. And what would this become?
1 and.
1 and. Good. Ready, set, here we go. There you go, there you go. 3, 4, and. Good job. Okay, so just like 4, 4, 6, 8, there are 6 beats in a measure, right?
Yeah.
Do you remember what the 8 is?
8 per the line.
Yeah, 8 notes.
Yeah.
Well, the 8th note gets the beat.
Yeah.
Okay, so this one is the 8th note right here. So if we were playing this one, right? 1, 2, 3, 4, 5, 6. Can we try that? Ready, go. 1, 2. Perfect. Good. And then we're going to take out this one. And I'm going to put a rest right there. Okay. So we have to make sure we don't play on the 3, right?
On the 3.
Yeah. So ready, 1, 2, 3, 4, 5, 6. Perfect. Good. So you have to organize all your sounds into time depending on the signature too,
Yeah.
right? So what if we did 3, 4? How many beats would be in a measure?
3.
3, yeah. So what do we want to put in the measure?
Can we put a quarter note?
Right here on beat 1?
Yeah.
Okay. Perfect.
And then a half note or
Half-
an eighth note. Yeah.
An eighth note. Let's do the 2 eighth notes. And we have one more beat.
And then another quarter note.
And another quarter note.
Yeah.
Perfect. All right, and let's play that one together. Ready? 1, 2, 3. Good. There's 2 sounds on that one beat, right? Cool. Good job. So pretty much all the music, the math is music, right? You just have to make sure you keep track of that steady beat, and it just translates to any key signature or any time signature.
Yeah.
Yeah. Good. Should we play them all? Yeah. Let's do the first one. Let's play it together. My cello. So how would we count this one?
1
One.
and 2 and 3, 4.
Good, let's play it. Ready, set, go. Yeah, there you go. How would we count this one?
1,
One,
2, rest. 4, 5, 6.
Perfect, let's do it. Ready, 4, 5, 6. 3, 4, 5, 6. Good. And how do we count the last one?
1, 2 and 3.
Yes, let's do that one. Ready? 1, 2, 3. Perfect. Good. Yeah, so how musicians improvise, creating their own music, and how they read it too, like you do in
Yeah.
orchestra, right?
Yeah.
It's all the same. You're constantly thinking about the time and subdivision.
Yeah.
Yeah, good. Well, thank you, Ryan.
All right, nicely done, Ambra.
Thank you.
So I see that you've got yourself a natural right there,
Yes.
Ryan, already having known a lot about music right there.
Right.
So the music department, so you're working with students from TK to 6, and are you introducing them to different instruments as you're doing music throughout the year?
Yeah, we do a lot of singing, and we do a lot of like hand drums, percussion instruments. We do a lot of small handheld instruments for the small ones. And then in 5th and 6th grade, they start orchestra and band.
All right, well, thank you very much for coming in today. We certainly do appreciate your time.
Thank
We'll be
you.
back with more right after this.
Our SpaceX Crew 6 mission safely returns to Earth. The tech demo hitching a ride on our Psyche spacecraft, and studying ancient life on Earth to better understand Mars. A few of the stories to tell you about this week at NASA. On September 3rd, the 4-person crew of our SpaceX Crew 6 mission, including NASA astronauts Stephen Bowen and Woody Hoberg, climbed aboard their SpaceX Dragon spacecraft and undocked from the International Space Station. They returned to Earth very early the next morning, splashing down safely in the waters off the coast of Jacksonville, Florida. The international crew contributed to hundreds of experiments and technology demonstrations during its 6 months in orbit. The no earlier than October 5th targeted launch date of our Psyche mission to a metal-rich asteroid is less than a month away. The Psyche spacecraft will have a hitchhiker on the trip, a laser transceiver for our Deep Space Optical Communications or DSOC technology demonstration. DSOC, the agency's first test of high-bandwidth optical communications beyond the moon, aims to show how lasers could increase data transmission rates far beyond the capacity of current radio frequency systems used on spacecraft today. Members of our Mars exploration program and several international partners recently went on a field expedition to the Western Australian outback to study some of the oldest confirmed fossilized life forms on Earth that may be relatable to Mars. Both planets may have had similar pasts, so learning more about the evolution of Earth may help us understand what we find now and in the future as we search for signs of ancient microbial life on Mars. An MD-90 airplane was recently flown to Boeing's Palmdale, California facility to be converted into the X-66A experimental aircraft for NASA's Sustainable Flight Demonstrator project. The X-66A, which will utilize a fuel-efficient transonic truss-braced wing configuration, supports the U.S. goal of achieving net zero aviation greenhouse gas emissions by 2050. That's what's up this week at NASA. For more on these and other stories, follow us on the web at nasa.gov/twan.
Always cool stuff going on this week at NASA, and we will be fortunate enough to have part of NASA visiting with us at Do the Math all throughout the season, finding about the latest test flights and things that are going on at the Armstrong Research Flight Center. 636-4357 is our phone number. We do have phone tutors available most of the year on Tuesdays and Wednesdays. We have Ryan, a 7th grade student at Warren, and feel pretty good doing that music right there?
Yeah.
Yeah, that's fun stuff, isn't it?
Yeah.
All right, well, we're going to get you back to even more fun because now we're going to talk about circles, and that will lead to something delicious right after this.
Yeah.
You ready?
Yeah.
So we're going to take a look at the circle, and Marylou has made it where it's got 32 centimeters, and that could be, I don't know, is that the radius, the diameter? What is that? And then we need to find the C and the A. So what do you think all that stuff means?
So that means the circumference,
Okay.
and that is the area.
Okay, so what is the circumference? Well, let's start with area. What's area?
The measurements of the whole circle.
Okay. Well,
Yeah.
if I had, let's take a rectangle, okay? If I had a rectangle and I asked you what is the area of the rectangle, are we talking about the outside running around the outside, or are we talking about everything on the inside?
The inside.
The inside. So the area of a circle
Is everything in the inside.
the inside. So
Yeah.
what's the circumference then? If we're talking area for everything on the inside.
Oh, the outside, yes.
The
There you
outside.
go.
It's the distance completely around the circle.
Circle.
So what is one thing that you do know about circles? What's like everybody talks
They don't have
about?
sides.
They don't have sides like this, right?
Yeah.
It goes, it's continuous around. But there's a certain number that is related to circles, and we celebrate it every single year because it's a day. It's also a day in a month.
Oh, Pi Day.
Pi Day, yes. Actually, a friend of mine was born on Pi Day, and I'm like, yes, so exciting. So what is pi? What is that number when we talk about pi? What is that?
A set of continuous numbers for on
Right.
and on.
It's actually called irrational.
Yeah, irrational.
Because
yes.
there's no endpoint, and people have not found the endpoint yet. But people are continuously finding another digit in pi, but nobody has found the end, right? That's irrational numbers. We've been dealing with rational numbers where, yes, there's a definite end to it.
Yeah.
But what is this number exactly? We use this symbol, but what is the shortened version?
3.14.
Right, it is 3 and 1400ths. It also is a fraction. There's also a fraction to that. But we're going to use the 3 and 1400ths for right now, okay? Because we need to use the number. How can we use the number? We need to shorten it, okay? So let's first talk about the distance around. If we were to cut this and open this up, and if we were to make it into pie pieces and open it all the way up, it's almost like taking a melon piece and cutting it and going whoop, right?
Yeah.
Fanning it out. It would actually almost come out to be like a rectangle.
Yeah.
So we know with like a rectangle, it's length times width, right, to find the area. But we need this right here. That is our diameter. We need that diameter in order to figure out our circumference.
Yeah.
We need our diameter and we need
Pi.
pi. Those are our two numbers we need to figure out the circumference. So what do you think we're going to be doing with 32 and 3 and 1400ths?
Multiply.
Exactly. Can you multiply those two numbers for me? However you want.
Okay.
You could erase that. Yep. Can you walk me through what you're doing?
So I'm just using the basic multiplication.
Okay.
So, what I learned was basic, but you first multiply with this one, and then you multiply with this one first.
Okay.
So we're going to be multiplying 3.14 times 2. So 4 times 2 is 8, 1 times 2 is 2, and then 3 times 2 is 6. And then you put a 0 here for multiplying.
For that place value.
Yeah. So now we're multiplying this number by 3. So 4 times 3 is 12. We put a 2. We add a 1 right here. 1 times 3 is 3. Plus that 1 is 4. And then 3 times 3 is 9. So then we want to worry about the decimal point.
Do we want to worry about that after we
Oh yeah, after.
add those
Yeah, after,
together?
yeah.
Yes.
So 8 plus 0 is 8 because there's nothing in 0. 2 plus 2 is 4. 6 plus 4 is 10. And 9 plus 1, because of the 1 that came up here, is 10. So our number is 10,048, but the decimal.
Right.
So there's so every time there's a decimal, you need to count how many numbers are past the decimal point. So now as we count here, there's 1 and 2 numbers past the decimal point. Let's bring it over here. There's 2 numbers past the decimal point. For this one, there's no decimal, so we count it as 0 numbers past the decimal point because there is no decimal. If we add these 2, we always add is 2. So now in our number, there is an invisible decimal point right here. We want to move it 2 times. So let's bring our decimal, 1, 2. So now our total number is 100.48.
So we have 148 hundredths. What's our unit of measurement?
Centimeters.
Centimeters. So that's our distance around the circle, right? But now we got to find our area.
Inside, yes.
Do you think we're going to need to use this diameter?
Yeah.
We do, but we also need to, oh, no, let me do another color. We also need what we call the radius. So when we have something that goes across the circle, that's a diameter. We also need the radius. And the radius is from the center out. So it's half of the diameter, right?
Yeah.
So what would be, I'm going to label that R, what's half of 32?
16.
16. Okay, let me erase R square. It's 16. So I know my radius equals 16 centimeters. So there's a fun formula that they found by, like I said, opening this up and finding out all this information. They found that if we take the radius squared and times it by
3
pi, we can find the area of a circle, okay? So we have our radius squared, and we're going to multiply that by pi. Or a lot of people like to say pies are squared. Not round pies, but a squared pie, right? Our exponent. So thinking about this, our pi, what is pi?
At 3.14.
Okay. And what's the radius squared, though?
16.
Squared, not 16 times 16, but we need 16 squared. So that means we're saying 16, or I'm sorry, not 16 plus 16, but 16
times 16.
Can you multiply those for me real quick?
Okay, so again, using the same thing we did up here, 6 times 6 is 36. We bring the 3 up here because 36. 1 times 6 is 6, plus 3 is 9. Again, we add our 0, and then 6 times 1 is 6, and then 1 times 1 is 1. If we add those two together, 6 and then 17, bring our 1 up here, so 276.
So 16 squared is 276. Now we have to multiply that by?
Hold on, brothers and sisters.
Did we skip
What's
something?
9 plus 6?
Hold on, 9 plus 6. Oh, what's 9 plus 6? I didn't catch that. What's
15.
15, there you go.
56, sorry.
Okay, 256. So now we have to multiply that by what?
Pi.
And
which
pi is?
3.1.
Okay, go for it.
So 256 times 3.14. So we're going to use the multiplication system that we did 2 times. So 24, bring the 2, 22, because you're adding the 2. You bring the 2 up here. Then 2 times 4 is 8, plus 2 is 10. And we add the 0 here. And then 6 times 1 is 6, 5 times 1 is 5, and then 2 times 1 is 2, add another 0. And then 6 times 3 is 18. We bring the 1 up here.
Right?
Yeah. Oh, yeah. And then we bring the 1 up here. So 5 times 3, 15. And then we bring the 1 up here again. And then 6 plus 1 is 7.
All right, do you need me to move that down
Yeah.
even more? There you go.
So 4 plus 0 is 4. Oh. We need to add a third 0. Sorry. We need to move all this back.
Oh, okay. Here, I'm going to write this down so you don't lose it. It's 7, 5, 8, 0, 0. All right.
Yeah.
Let's go ahead and move that over.
Okay. 7. Oh.
Wait, one more.
Yeah. 7, 5, 8, 0, and then
0.
this
There you
0
go.
right here.
Okay.
Okay. So 2 plus 6 is 8, plus 0 is still 8. And then 0 plus 5 is 5, plus 8 is 13.
Carry your 1.
2.
Yeah.
Yeah. So 1 plus 2 is 3, plus 5 is 8, plus 1 is 9. So it's 9. And then 7 plus 0 is 7.
Okay, and then our decimal.
And then our decimal. So this one has 0 decimal, so it's 0. And then this one has 2 decimals.
Okay.
So it's 2. It's because it's 2 numbers to the right of the decimal. So 2 added together, those are 2. So if we have a little invisible decimal point right here, we bring it 1, 2, right there. Our decimal point is right there. So our number is 793.
793 and 84
84
hundredths.
Yeah.
Yes. Now it's not just centimeters. Area is what? Centimeters?
Squared.
Or squared centimeters,
Yeah.
right? It's squared centimeters. So there's a huge difference. If this was something I was running around, right? There's even more on the inside, huh? There's more area on the inside than what we're seeing running around on the outside. Wow, whoosh, is your brain hurt right now? That was a lot of math.
Well, I hope it's not hurting too much because you're not through.
Oh no.
Okay, we're going to go down here, and
Okay.
Ryan, I'm going to give you this calculator. And
There
I'm
you
sure
go.
that you've used tools in mathematics before, correct?
That's all you
Yes, I have.
A calculator is an essential one to use at times. What I would like you to do is don't erase anything. Leave.
Yeah.
So you can.
Oh, I just erased
So
that.
right. So do your 256 times 3.14 again.
Uh-huh. Uh-oh.
Oh, 803.
Oh.
So you were right because I was watching it and I'm like, I know it's got to be in the 800.
Okay.
So,
Trying to see where we made
what I
that
want you to
mistake
do
at.
is with Marylou, take a look at your multiplication and see if you can figure out where something may have happened.
So let's start
And I'm
with.
going to give you 90 seconds to see if you can figure it
Okay.
out.
4 times 6 is 24.
24.
We had your 2, right?
5 times 4 is 20, plus 2 is
22.
22. And then 8 plus 2 is 10.
Okay, that's right.
Good. 0,
There's-
and
you have your
then
0, you have your 6, 5, 2. That's
Good.
right. 0, 0, 8,
18,
18, 15. Oh, 16. We forgot our 1. No, wait, no?
Oh, they gave you the buzzer.
Is that it? Did we not get it? Hold on.
3
There's
times 5 is 15
18
plus the 1 is
1.
16.
You forgot right there. We forgot that
That's
1.
where the 9 now becomes a 0.
All right, that becomes a 0, and that is 8.
8.
There you go.
Oh,
So
3.
Oh my goodness.
if you have the use of a calculator, when you're doing big multiplication like that, because a lot of times you understand the process of how to multiply and what to do, right?
Yeah,
You
yeah,
understand that.
yeah.
So there's not a problem with ever checking to make sure that what you have just done is actually correct. Now, Ryan, you're a sharp student. Do you think all students will take the time, the 5 seconds to check most problems?
No.
No, they won't, right? And then they do all of that math and they turn it in and they have 793.84 and the teacher goes, oh, you were so close. I know you know what you're doing, but there was just a mistake in something simple like that.
Yeah.
So if you think about it, always try to check your work, and it's something that won't take much time, but will be of much help. And we'll be back right after this, learn a little bit more about the state parks.
Have you ever visited California's redwood forests? Explored the vast desert? Felt the power of the Pacific Ocean? These adventures and more can be yours to discover with the free California State Park Adventure Pass. Available to 4th graders and their families, this pass provides free access to select parks throughout California, waiving the day use and entry fees for a full year. With a variety of benefits including access to museums, historic sites, and natural parks, adventure awaits you. Visit our website at parks.ca.gov/adventurepass to get your free pass and learn more about this program. Let your adventures begin at California State Parks. Hi, I'm Lydia here at beautiful Anza Borrego Desert State Park, California's largest state park in San Diego, Imperial, and Riverside counties, home to the impressive peninsular bighorn sheep and countless other incredible plants and animals. We are so excited to be one of the 19 California state parks participating in the California Adventure Pass program. This pass is available for California 4th graders and their families, waiving day use and entry fees to give families the free opportunity to visit 19 California state parks for a full year. Our park has over 500 miles of dirt roads and countless trails to explore and discover, as well as a unique visitor center hidden underground to mimic the homes of wildlife in the desert. Visit our website at parks.ca.gov/adventurepass to get your free pass or learn more about this program. Let your adventure begin here at Anza Borrego Desert State Park.
A nice reminder right there about the Adventure Pass that 4th grade students can get for absolutely free to visit 19 California state parks. And also a big thank you to Daniel Williford today for visiting us via Skype and explaining a little bit more about those programs and how people can take advantage of those. And very, very simple things. Simply go to the website and get all the information, and then you're going off to all of the different state parks during the entire year. And it has just started. It's good from September 1st, and we're only on the, what is it, the 12th today right there?
I'd love
so
to
you've
do the
got
train.
11 and a half months to do that.
Yeah.
So, Ryan, 7th grade student from Warren Junior High. Did you have fun today?
Yes, I did.
That's pretty good, huh? You did. I bet you didn't know you were going to be doing some music today either, did you?
No, I did not.
All right. Now, I know you guys were talking about pi r squared, right? You were talking about square pi, right? Do you like pie?
Yeah.
What's your favorite type of pie?
I've only had one type. Apple.
Oh, so you're
Yeah.
talking about the fruit pie.
Yeah.
We're talking about the pizza pie. So do you know pizza pie?
Yeah.
Okay, so see, back east we call that pie, right? So if you had a square pie, do you know what type of pie that is? Have you ever seen a square, what you guys call pizza?
Yeah.
Do you know what that type is called?
A square pizza.
Yeah. Oh, no, in Detroit.
Neapolitan also,
Yeah.
right? So we don't want to talk about the Detroit thing because then they were all mixed up and stuff like that. But anyway, I'm glad that you were here today. You had fun?
Yes, I
That's
did.
the important thing. Until we meet again, continue to do the math.
Major support for Do the Math has been provided by Chevron, the Kern County Superintendent of Schools, Edison International, Valley Strong Credit Union, Panama Buena Vista Union School District, and the Kern High School District. With additional production assistance provided by these supporters of education in Kern County and throughout the state of California.